Hi guys, welcome to the class. In this lecture, we're going to see what are the different types of formworks and what is meant by a formwork and what are the different materials used for the formwork and the main properties of the formwork in the construction role. So, what is meant by formwork? Formwork is nothing but mold including all the supporting structures used to shape and support the concrete until it attains sufficient strength to carry its own weight. So, formwork is nothing but a mold which is helps to support the concrete materials to shape and also support these concrete materials until the concrete which we poured into the formwork molds to get sufficient strength to carry its own weight, and it should be capable of carrying all imposed dead load and live loads apart from its own weight. Formwork. There are two types of formwork commonly made of the steel and timber. So here in this picture, you can observe this is the timber formwork. We can see the formwork which supports the concrete which the material poured into to get perfect shape and strength, desired strength to carry its own self weight of this concrete. So the timber formwork here, you can see these are the shear walls here. So there is no brickwork can be seen here, only the concrete arrangements of the walls also be made by these type of formworks here. The structure which is going to be constructed is a shear wall. So these are the steel formwork. These are uh, the timber formwork which must be water resistant, which can bear the material and the dead load and the live load which is going to be present on this formwork and by its and also its own weight. So the steel formwork here, the H frames are arranged in order to in order to develop the height of this formwork. These are the H frames here, so that the formwork may contain uh, same properties which is going to be provided same as that of timber formwork. So formwork has been in the use since the beginning of the concrete constructions. The new materials such as steel, plastic, and fiberglass are also be used in the formwork. So the greater attention is being given to this design, fabrication, erection, and dismantling of the formwork. The formwork is designed according to the ACI document SP4. The major qualities required for the formwork are it should be water tight and it should be strong. So it can also be reusable. Its contact surface should be uniform without any undulations, and it should be according to the size of the member. So the major qualities of homework are it should maintain the water tightness. So it must carry the water content present in the concrete material, concrete. So the watertight bonding, the formwork must act as a water tight material so that it cannot percolate, it cannot infiltrate, or it cannot be pervious to the water present in the concrete materials. So it should be also strong enough to withhold these type of loads, and also the steel reinforcement which is going to be provided for the slab constructions. So the formwork must be strong enough to carry the dead load and also the live loads imposed on that formwork. And these formwork should be capable of reusable, so that when the concrete attains its self weight, uh, concrete attains its own self weight to maintain the stability of the structure. these formwork can be removed, so that these formwork which has been removed also be reusable. So its contact surface should be uniform. The contact surface which we provided by using of this formwork should be uniform without any undulations, so that the slab or the members which we are casting should be in the perfect shape and attain without any curves or undulating surfaces on that casting material. So it should be according to the size of the member. The size of the slab we are laying is of 20 into 40, so that the formwork should be of that same size. It should not be any extra or should be short, so that the additional pieces must, when we provide an additional joint to this formwork, the leakages may be happen, so that the water, the bleeding of the water which can be uh, helpful for the percolating of these gaps which we have provided on the joining of formwork. So the major qualities of the formwork are to must be a watertight, and also should be strong enough to withhold these imposed or dead and live loads, and it can also be reusable. Its contact surface should be uniform without any undulations, and it also to be according to the size of the member which we are going to be cast. So in order to successfully carry out its function, the formwork must achieve a balance of following requirements. The formwork must be containment, strength, resistance to leakage, and accuracy, easy of handling, and finish and reuse potential, access for concrete, and must be economical. So the formwork must be capable of shaping and supporting the fluid concrete until it cures, until it gets sufficient strength to withstand its own self weight, so that the formwork must contain the fluid concrete which we are poured into those formwork must be capable of shaping and supporting the fluid concrete until it's get its own strength. It's get its own strength to withstand. And strength, the formwork must be capable of safely withstanding without distortion or danger. The dead weight of the fluid concrete is placed on it, the labor weight, equipment weight, and any environmental loadings. Like if there are any heavy winds blowing towards this formwork, if the construction is on a particular place where there are no buildings surrounded, the wind load can also be uh, much dangerous when we cannot consider it. So the strength of the formwork must be capable of safely withstanding any without distortions or danger. If when we apply any load, the concrete load or the equipment load or the live or the weight of those labor who are moving on this formwork must be must be withstanded by the formwork. Is there any distortions? Is there any distortions? The danger of the formwork can be broken, and the danger can happen at any place. So these formwork must bear the dead weight of the fluid concrete which is going to be placed on it, and the labor weight, and also equipment weight, and if any environmental loads applying on those formwork. So these formwork must be strengthened to withstand all these loads. The ease of handling. Foam panels and units should be designed so that the maximum size does not exceed that which can be easily handled by hand or mechanical means. The ease of handling. The foam panels and units should be designed. The panels which we are going to be fitted in those formwork must be designed to their maximum size does not exceed, so that the easy of the handling of these formwork materials can be easy, and they can be carried to the site. They can be fitted by hand or mechanical means. In addition, All formwork must also be designed and constructed to include facilities for adjustments, leveling, easing, and striking without damage to the formwork or concrete. The formwork which we arranged, is there any undulating surfaces, or the surface should not be leveled properly, so that these when the striking, the when we applied to maintain the surface at leveled process, when we apply some loads to maintain the leveling of the formwork, or the small parts of the formwork can be cutted, so the easing and striking without damage to the formwork or concrete we provided must be maintained. Economy. All the formwork is very expensive, on average about 35%, about 35% of the total cost of any finished concrete unit or element can be attributed to its formwork. Of this, just 40% can be taken for material for formwork and 60% for labor. So when we compare to the economy of the construction of the whole building, the major role played by the formwork is of 35% of the whole construction process. The total cost of any constructed, any finished concrete unit or element can be attributed to its formwork. Just 40% of the material for formwork and for 60% for the labor can be used, so that the formwork designer must therefore not only consider the maximum number of times that any form can be reused, but also produce a design that will minimize the time taken for action and striking. So the formwork designer must keep an eye on the process of the manufacturing of these formworks and placing of these formworks in a particular manner where these materials can be reused. These formworks which we are used for the single constructions, so that these formworks can be reused, and also produce a design that will minimize the time taken for erection and striking. So the major objectives considered in the formwork are the quality of the formwork, the safety, and economy. So here, considering the quality of the formwork, the forms must be designed and built with sufficient stiffness and accuracy, so that the size, shape, position, and finish of the cast concrete are maintained. The forms which have high quality must be designed and built with sufficient stiffness which can and accuracy, so that the size and shape and position and also finish of these cast concrete are maintained. So if the formwork is not properly designed, properly built, so the shape of this concrete casting of the concrete may not be maintained. And also if the quality of the formwork material which we are going to be used is not high, so that the strength bearing capacity of this formwork, when the fluid concrete has been poured onto this formwork, they may not withstand of these heavy loads, and also the labor weight also be seen on this formwork, and also the striking of the formwork can be seen on that. On these live loads or the imposed loads and additional environmental loads can also be applied on these formworks. So the quality and the quality measure, majority of the strength of the formwork should attain the qualities of the construction, the casting of the concrete, so that the safety plays a vital role. The forms must be built sufficient strength and a factor of safety, so that they have the capability of all supporting loads. So these forms, previously we have discussed, these forms must be designed according to the loads, and also a factor of safety can be applied while designing of these formworks, so that these formworks are capable of all supporting loads. Economy. The forms must be built efficiently, minimizing time and the cost of the uh, materials which we are going to be used for the forms, so that the forms must be built efficiently, and also minimizing the time of this manufacturing of these forms can also be reduced, and the cost for the manufacturing of these forms can be reduced. It depends upon the economy. What are the major requirements of formwork? The material should be cheap and reusable. So the required material which we are going to be used for the formwork, the material which we are going to be used for the formwork should be very cheaply available, and also it can be reusable. It should be practically waterproof so that it should not absorb water from the concrete. If the material which we are going to be used for the formwork is not a waterproof material, so that the water absorption from the concrete can be seen on that formwork, and it is not as good as for the construction of these cast of concrete can be seen. So the waterproof material can be used for the formwork, so it may not absorb any water present in the concrete. The swelling and shrinkage should be minimum. The swelling and shrinkage should be minimum. The strong enough to withstand all external loads. These formwork which we are going to be used uh, are too strong enough to withstand all the external loads applied on those formworks. The deflection should be minimum. The deflection, when the application of the load, is there any dead load or live load or the imposed load which are going to be applied on the formwork, the deflection carried by the formwork should be minimum. The surface should be smooth enough and afford easy stripping. The surface should be smooth enough that the easy in the stripping, the removal of these materials can be easily removed, detached from the casting of the concrete. When the concrete attained its self weight, its sufficient strength to balance its own weight. The foam material which we are going to be used are light in weight, so that they can be easily transferred and can be lifted and can be operated by the hand itself. The joints should be stiff so that the lateral deformation and a leak is minimum. So the foam materials which we cannot be manufactured as long as the construction site, so that the pieces which are going to be jointed should be stiff enough so that the lateral deformation and these joints can also be helpful in the minimum leakage of the materials. So the leakage should be minimum, and the joint should be stiff enough so that the lateral deformation should be minimum. There are three stages in the process: assembly and erection, concrete placement, stripping and dismantling. So the formwork detail for different structural members. In concrete construction, the formwork is commonly provided for the following structural members: for wall, column. If the walls which are going to be constructed designed as shear walls, these walls can be provided with the formwork, so that the columns, slabs, beams, and stairs, chimneys, water tanks, cooling towers, these are all these are all the concrete construction for concrete constructions where formwork is necessary. Formwork for wall. It consists of timber sheeting, vertical posts, horizontal members, rackers, stakes, wedges. Here, after completing one side of formwork, the reinforcement is provided at the place, then the second side formwork is provided. Here, for construction of the shear walls, first we have to provide a timber sheeting. We have to provide a timber sheeting to support those timber sheetings. These vertical posts are placed under the horizontal members for which helps for the timber sheets do not break on the applying of fluid concrete. These rackers, stakes and wedges here, these are the rackers which helps uh, for the balancing of horizontal members which is supported to the timber sheeting, and these are the wedges where these cannot be, these are the uh, posts which are provided for the timber sheeting, and stakes driven into the ground to support these rackers which give uh, perfect support to the rackers we provided, so that to when the fluid concrete has been poured into this mold, this load has been applied to the vertical post, then transferred to the horizontal members, and these horizontal members can be placed in position by the rackers. If the load cannot be heavy, so that these rackers are helpful uh, by the support helps taken by the support of the stakes which are driven into the ground. After completing one side of the formwork, after completing the one side here, when we place it timber sheeting which is supported by the vertical posts, those are supported by the horizontal members, and those all the members are being supported by uh, rackers and wedges. These rackers are helpful to withstand heavy loads with the help of stakes driven into the ground, so that after completing of the one side, the reinforcement has been provided, so that the other side of the wall can also be placed. The second side of the formwork is also be provided likewise, where after that the fluid concrete can be placed for the formwork for column. It consists of the following side and end planks, yoke, and nut and bolts. Two end and two side planks are joined by the yokes and bolts. Here, these are the side planks. This one, and this one. These are all the side planks. These side planks are fitted with two ends, and two side planks are joined by the yokes. These are the yokes. The horizontal members which gives support to the columns are yokes. These yokes are joined. These side and end planks are joined by bolt fitting here, so that the when we pour fluid concrete into the column, the leakages cannot be seen here, so they are tightly fixed to one another. The formwork for columns, you can observe here, these are the formworks provided for the columns. This is the woodwork, this is the steel formwork. Formwork for slabs and beams. It consists of sole plates, wedges, props, head tree, planks, batten, ledgers. Here, the beam formwork rest on head tree. The slab formwork rests on battens, rest on batten and joys. If prop height are more than 8, provide horizontal braces. Here, this is the slab we are going to be pour, and these are the slab sheetings, and here you can see this is the slab formwork, and this is the pole which is nothing but batten to place the surface to be leveled surface, so the battens and the joists which are helpful on the beams we have casted previously. Here, this is the header tree where the beams has been poured. This is the cleat, and if the height of the slab which we are going to be designed is more than 8, we provide horizontal braces. These are the sole plates. The formwork for concrete beams and slabs. Lintel or beam formwork. Lintel or beam formwork. There is a 15 thick plywood sides are applied on the sides of this. So this is the lintel or beam formwork. Here you can see these are the braces to support this extension of this formwork, and a 15 thick plywood side beam sides are arranged here, and a cleat to support this beam sides strut, nothing but a strut which is supported by cleat without any movement. When we poured the fluid concrete here, the load applied by the material can push these side racks aside, so that to avoid these, a strut has been provided, and this strut has been balanced, can be placed in position with the cleat here. So this is the runner to maintain the surface leveled. uh, Formwork for slabs. Here you can observe there are this is the formwork, and here this is the formwork supported to give shape and strength for the concrete which we poured for laying of slab. Formwork used for stairs. Formwork used for stairs. It consists of vertical and inclined posts, inclined members, wooden planks or sheetings, stringer and riser planks. These are the 4 centimeters planks. This is the upper beam of landing. Here you can see this is the landing portion, and here a post has been supported. These are the stringers, and inclined members can be seen here from landing to the lower beam. Here these are the inclined members, and this is the wooden planks or sheeting for the landing can be seen. This is the 3 centimeters sheeting where the inclination of the stairs can be placed. These are the riser planks. This is the support post to support the uh, fluid of concrete which has been poured onto the landing area. So the amount of load is high, so that these posts can support the material. These posts support the material. So the formwork for stairs. Here you can observe these are the cross joists, a strut which helps in which helps without bulging of the side work which we provided, cut strings and risers and the stiffeners and string. These are the hangers. So you can observe here in this image, this is the formwork which are used for the stairs. Formwork for spiral stairs. Formwork for spiral stairs. The formwork for chimneys. For tall chimneys, two types of forms techniques are generally used in our country: the jump form or slip form. The removal of formwork. Time of formwork removal depends upon the following factors: the type of cement which we are used in the preparing of the concrete. The rapid hardening cement requires lesser time as compared to the ordinary Portland cement. So the rapid hardening cement requires, so when we use ordinary Portland cement, the strengthening, the sufficient time required for the strengthen of the concrete is high when compared to that of rapid hardening cement. So the ratio of concrete mix, the rich ratio concrete gain strength earlier as compared to weak ratio concrete. The weather conditions, the hydration process accelerates in hot weather conditions as compared to cold and humid weather conditions. Time of removal of formwork. Structural members. For beam sides, walls, and columns, for ordinary Portland cement, it takes about 2 to 3 days. For rapidly hardening cement, it is about 2 days. For slab, the vertical support remains intact for 4 days of the ordinary Portland cement and a day less when compared to that of ordinary Portland cement for rapid hardening cement. For slab, the complete formwork removal can be observed for OPC of 10 days and for rapid hardening cement is of 5 days. For beams, the removal of sheeting props remain intact. So for removal of all formwork for the beams and arches for OPC it takes about 14 days. For rapidly hardening cement, it is about 5 to 8 days. Uh, for beams and arches, complete formwork removal more than 6 meters span is of 21 days for ordinary Portland cement and for 8 to 10 days required for the removal of formwork when the beams and arches are more than 6 meters span, it can be seen of 8 to 10 days for rapidly hardening cement. So these are the different types of structural members which we use formwork for, and the number of days required for the removal of formwork for ordinary Portland cement and rapidly hardening cement. So when compared to these two types of cementitious materials, the uh, formwork removal procedure can be number of days can be seen for OPC when compared to that of rapidly hardening cement. For removing of, it takes about half period. If the OPC takes about 10 days for removal of the formwork, for 5 days can be seen in the rapidly hardening cement. The cantilever slab. Here, the first free end support should be removed. The first free ends support should be removed, and then from right to left, and then from right to left, it should be proceed. If we are removing from the mid span, then it will act as a proper cantilever beam. If we remove the support from the mid-span, it acts as a proper cantilever. So the supports which we provided for the casting of this concrete. So when we casting the cantilever slab, the first free end support which we provided for the support as for the concrete casting can be removed, and then from the right to leftwards, then from right to leftwards, these should be proceeded. This processor of removing of the supports can be proceed. If we are removing from the mid-span, then it will act as a proper cantilever slab, a proper cantilever. So for the simply supported slab, in simply supported slab, we have to remove the support from the mid-span to the ends to meet this behavior is helpful to meet the design behavior of the simply supported slabs. If we have not followed the removing of the support span from the mid of the for the simply supported, these design behavior cannot be seen. So to meet this simply supported design behavior, the supports which we provided can be removed from the mid-span to the ends. Maintenance of formwork. Maintenance of formwork. Due to continuous use wooden planks and steel plates, surfaces become uneven and require maintenance. For wooden formwork, use cardboard or plastic fiber board. Bolt hole places must also be repaired. uh, these when we are using the wooden formwork or the use of cardboard or plastic fiber boards in the process of formwork for the casting of concrete, the bolt hole places when we drilled, when we joined these both formworks, these bolt hole places must also be repaired after the removal of formwork from the strengthened concrete, so that these uneven surfaces also be required maintenance. For steel formwork plates, must be leveled by mallet and loose corners must be welded. If the steel formwork, which we are going to cast concrete, these steel formwork plates must be leveled by using of mallets, and also the loose corners where welding needed can be done. And the cost of formwork. For normal works, the cost of formwork is about 30 to 40% of the concrete cost. For special works, cost of the formwork is about 50 to 60%. Is about 50 to 60% of the concrete cost. The formwork work cost is controlled by the formwork material cost, erecting cost, and removal cost. So this formwork cost is not only uh, observed, is not only seen while the construction process, while preparing process of this formwork. This a cost of the formwork, including of material cost, the design cost, and the after curing, after casting of the concrete, the removal cost, and also the jointing cost, the nails and cables which require for the joining of these formworks, also including the cost of the formwork and the labor charges who fitted the formwork. So these are all the factors. These are all the factors for formwork cost can be controlled. If the formwork material cost is less, and the erecting cost, the removal cost, and also the jointing cost, which is used by nails and cables, and the labor charges. So these are all the costs which include in the process of maintaining the cost of the formwork, maintaining the cost of the formwork. The major advantages of steel formwork are it can be used for a number of times, and it is non-absorbent, and a smooth finish surface can be obtained by using of these steel formwork, and no shrinkage of formworks can be seen in this type of formwork, and they are easy to use, and its volume is less. Its volume is less, and the strength is more when compared to the other form of formwork which we have used. The loads on formwork. What are the different types of loads which are placed on the formwork? Are dead load, imposed load, horizontal loads, and environmental loads. The dead load includes the self weight of the formwork, the pressure and loads from fresh liquid or fluid concrete, and the reinforcement which is provided for slab designs like that. And the imposed load, like construction workers, the labor weight, the stacking of materials, the materials which we use on the slab, like vibrators, the materials, the lifting materials, the pouring of concrete and the distribution of these concrete materials to certain parts, uh, the stacking of materials, and the horizontal loads like environmental loads, the accidental loads, and also wind loads. These are the types of loads which are seen on the formwork, and these formwork can withstand, this formwork which we are going to design can withstand all these type of loads. So these are the references. Thank you, and see you in the next class. See you in the next class.